Alright, this is a video lesson for Unit 9, Lesson 1, which is negative and zero exponents. So Unit 9 is all about these guys that we call exponents. We're going to talk in the next page about what an exponent is. But there's lots of rules that go with exponents, and the first two we're going to learn about are the negative and zero rules. So what's an exponent? An exponent is the little symbol up here, and it tells you how many times you're going to see a particular number in a number chain or a multiplication chain. So this whole thing is called a power, and within the power we have a base, which would be this number right here, and then we have an exponent, which is the number up top. So the exponent tells you how many times you'll see the number in the base in a multiplication chain. There's this tricky little way of understanding it. It's actually kind of simple. It's just 1 doesn't affect a number chain or a multiplication chain. So if we throw 1 at the end of any multiplication chain, it doesn't matter. It's just there. Okay? It disappears. So when I see something like 3 to the 5th equals 243, it's because we're saying 1, 2, 3, 4, 5 3's go into the multiplication chain, because 5 is the exponent. Now, one of the special rules is what happens when the exponent equals 0. Well, when the exponent equals 0, we're saying that there's no a's in the multiplication chain. So it's, if we had a to the third, it would be a times a times a with that sneaky little 1 multiplied in. But if it's a to the 0, that means no a's, and then just the 1. So we just have 1. And that's true for any base. No matter what the base is, we're going to get 1 if we raise it to the 0 power. So that's an important rule to know, because it's a really simple rule. If you see a 0, no matter what's under it, we're just going to call it 1. Now, negative exponents have a very special rule to them. If you saw something like 2 to the negative 4th, it would really turn into 1 over 2 to the 4th. Okay? And the way negative exponents work is it works as like a message that says, I'm on the wrong side of the fraction. So it's actually easier to understand this if I have a full fraction. If I had something like 3 to the negative 5th and 6 to the negative 2nd, this negative 5 would be telling me that the 3 to the 5th is in the wrong place. It needs to go on the other side of the fraction. It needs to go down. This 6 to the negative 2nd would be saying, oh, this 6 squared, it's in the wrong place. It needs to go up. So this would actually turn into 6 squared over 3 to the 5th. Anytime you see a negative exponent, it's a message, I'm in the wrong spot. And we're going to see this with a lot of examples, but let's look at, like, if I had something like 1 over 3 to the negative 7th. As soon as you see a negative exponent, it goes, oh, this is in the wrong spot. I need to move it. So I'm going to move it up. 3 to the 7th moves to the top. Well, the bottom would just be 1, and that would disappear. So our answer would be 3 to the 7th. Okay? The simple way of writing this is a to the negative nth equals 1 over a to the nth. Because if I had a to the negative nth, it's saying, oh, this is in the wrong side. Well, I don't see a fraction. Just draw a fraction bar. Now you see a fraction. A to the nth is in the wrong spot. It needs to move down. So this turns into nothing over a to the nth. Well, it's never really nothing. If one side of a fraction is empty, there's always a 1 there. So that's how we get 1 over a to the nth, which is this rule. I think this rule starts to make more sense when you see examples, so if you're a little overwhelmed, don't worry about it. Okay? Over here, second half of this rule, if we have a to the negative nth, really it's saying I'm on the wrong side. I'm on the bottom, I need to be on the top, so we really should have an a to the nth when we see 1 over a to the negative nth. So those are the only two rules we're going to work with, is 0 property and the negative exponent property. So for this first problem, we're going to start doing examples now. For this first problem, I have a negative exponent which means wrong side of the fraction. So I need to draw a fraction bar, and I'm going to move this whole thing down. Now, the negative exponent isn't just talking about the 4. It's talking about the whole 3 to the 4th. So all of that 3 to the 4th needs to move to the bottom. The top or bottom of a fraction is never truly empty. There's always a 1 there. So really we have 1 over 3 to the 4th. And that's our answer. Second problem. Uh-oh. Negative exponent means wrong side of the fraction. So I'm going to move this up, but that means I'm moving all of x to the 4th to the top. Now, the bottom's never really empty, so there's a 1 there, but we don't need to show dividing by 1. That doesn't do anything. So I'm just going to say x to the 4th. And that's our answer. Now, number 3. Important to understand, this negative 7 is going to the x, not to the 5. The 5 is its own thing, its own power. It's really like 5 to the 1st. So the negative 7 goes with the x. So the 5 is fine. It's on the right side of the fraction. The problem is this negative 7 going with this x. That's on the wrong side of the fraction. That needs to move down. So the 5 gets to stay up top. The x to the 7th moves down. Now be careful. You notice I'm not writing x to the negative 7th down there. Once I've moved it, I don't need the negative symbol anymore. And this problem would be over. There's nothing more for me to do at this point. Number 4. This 2, totally fine. There's no negative exponent with it, it's fine. This 3, totally fine. This x to the negative 5th, that has a negative exponent. That needs to move. So the 2 is going to stay up top, the 3 is going to stay down low, and the x to the 5th is going to move to the top. And that's going to be our final answer. Now we're going to move into just a couple of the longer, slightly harder problems. So number 5. We're going to look at this in different pieces. The 5 is fine. There's nothing wrong with that 5. It's fine. The x to the 4th is fine. That's a positive exponent. The y to the negative 2nd, that's not good. That needs to move to the other side of the fraction. The x to the 0, well remember, z to the 0. Anything to the 0 power equals 1, so really we don't have a z to the 0 there, we have a 1. But multiplying by 1 doesn't really do anything, so that's going to go away. So we're still going to have a 5 up top, we're still going to have an x to the 4th up top. We're going to have a y squared move down, and our z to the 0, it goes away because it's really just 1, and 1 doesn't do anything. And this is going to be our final answer. Last one of these. 8 over 12. That is a fraction that can be reduced. We could divide the top and bottom by 4 to change that from 8 over 12 into 2 over 3. And we need to do that. You can't have unsimplified fractions in here. Now, x squared, nothing wrong with that, so I can rewrite that up top. Y to the negative 5th, that is a negative exponent, and it needs to move down. So y to the positive 5th gets to move to the bottom. W to the negative 2nd, that's a negative exponent. That needs to move up. W squared can move to the top. The only thing I haven't talked about yet is this z to the third, which should stay down low. And now I've addressed everything. I've changed the 8 over 12 into 2 over 3. I've left the x, so I took care of this. I left the x up top, because that's where it belongs, up top. I moved the y to the fifth down to the bottom. I moved the w squared up to the top. And I left the z cubed down on the bottom. Everything is exactly where it's supposed to be, and that means there's nothing left for me to do. Problem over. There's a lot of different rules to deal with in this chapter, but the first two we've got to be really good at right now. And that is, if I see a negative, it's on the wrong side of a fraction. And if I see a 0, it's really just 1 and I can get rid of it. And that's it for this lesson.